Hello everybody and welcome to our lesson on section 4D, natural logarithms. So the natural logarithm is a little bit new to you in calculus, but we do use it quite a bit in calculus. And it's just a specific logarithm. So first we have to talk about the value of e. In math, some numbers are so useful that we give them their own names. A good example is pi. Okay, we use pi in calculating areas of circles, and we use it a lot, so that's why we have it has its own symbol and its own name. Another useful number with its own name is e. E is equal to approximately 2.71828, but just like pi, it continues on indefinitely. Okay, it is irrational. E is usually used as a base when exponential data is being examined in science, engineering, and finance. And for example, you don't need to write this in your notes, but if interest is paid continuously or instantaneously, then the formula for calculating a compounding amount that we've seen in previous years could be replaced by u sub 0 e to the RT, where e is the percentage rate per annum and t is the number of years. Your textbook has a full investigation on this. You could also take a look at this video. I'll put the link to this video on our notes, but I really like how it describes what the number e is and where it comes from, and how it has this financial application. Now, what is the natural logarithm? Where does e come from, essentially? Well, we have a function f of x equals e to the x, and it is the inverse of log base e to the x. Okay, so just like we have log base 10 to the x, and its inverse is y equals 10 to the x, well, e to the x has its own logarithmic inverse. Okay, and because e is so special, its logarithm is also special, and we use ln x. Some people say ln x, and some people read it as ln x. I'll read it as ln x, to represent the natural logarithm of x. So y equals ln x is a reflection of y equals e to the x in the mirror line y equals x. Okay, so we have our exponential function y equals e to the x going through these key points, 0, 1, and 1e. And we have its inverse going through the opposite key points of 1, 0, and e1. And that is the function ln x. A couple important things to note, that ln 1 is ln of e to the 0, which is 0. Okay, so ln of 1, remember that ln is log base e to the x, so that e to the what gives me 1? The answer is 0. Ln of e is ln of e to the 1, which is just 1. Ln of e squared is 2, etc. And we can rewrite these. If ln of, remember ln is like log base e, so log base e of e to the x is equal to x, and e to the ln x is equal to x. That's like our cancellation laws. Okay, and that we can rewrite some expressions in terms of e. So we can say that a to the x is equal to e to the x times ln a. We're going to use that in a future example. So some very simple examples here. Ln of e cubed. Remember that this is the same as saying log base e of e cubed. And since we've got a base of e and a base e here, they cancel out and leave me with just 3. So ln of the cube root of e is the same as saying ln of e to the 1/3. Remember that there's a base e and this is an e, cancels out, gives me 1/3. And here I could combine e and e to the a into e to the a plus 1, and then I can drop the e because of the cancellation rule. We can also rewrite in terms of e to the k using a little trick that we've seen on the previous page. Oops, sorry, let me just slide this down here. So I want you to think, if I want to rewrite 60 in terms of e to the something, remember that x is equal to e to the ln x because of that cancellation law. So if I want if I want to write e to the something gives me 60, I can say that 60 is equal to e to the ln 60, and ln 60 is 4.0.